Good morning, good afternoon, good evening, or good night, wherever you might be. My name is Khalid Isa. Today, myself and my colleagues, Jordan O'Connor, Samuel Andreas, and Ali Al will be talking about the Dole Packaged Foods Canada case. So, what is their challenge? The challenge they're facing is excess and obsolete inventory, specifically in the fruits industry, as that's the industry they're in. And if you don't know, unfortunately, around the entire world, not just in Dole's food, there's a lot of excess and obsolete food that's going to waste. For Dole specifically, 18% of their fruit losses ends up in landfill. So our challenge was to try to find a solution to solve this. In order to do this, we had to get a better understanding of the industry itself and of fruits. So we sat down with a professional logistics, a professor who's in logistics, and he told us about one of the ways they grade fruits. So we have grade A fruits, which is the high quality and appealing fruits. These are usually the fruits we see in retail stores and are targeted towards customers. Then we have the grade B fruits. These are slightly less appealing fruits, usually targeted to food services such as restaurants. After that, we have our grade C fruits. These are the fruits with noticeable defects and usually sent to processing. And finally, grade D fruits. These are the inedible fruits usually sent to waste. Now that we have our fruit grades, let's move to the supply chain. Starting with the supplier and farm supply chain, we have all the 4 grades of fruits there, grades A, B, C, and D, where A through C are sent to the distributors, but unfortunately grade D is sent to landfill. Then in our distribution centers or warehouses, we have grades A and B being sent to retail channels, while grade C sent to industrial food processors, and grade D again in landfills. And finally, in the retail channels, grade A makes it to the end customer, grade B goes to food services, and grade C and D go to landfills. So you can see here that in each stage, we have some E and O. So let's start with the supplier/farms. One of the way we plan to decrease the grade D there is by sending 50% of the waste to our first solution, which is the aerated static pile composting. Then moving on to the second phase of the supply chain, we plan to reduce 70% of the grade C that's being sent to the industrial food processors and sending it to our jelly and jam maker, which is our second solution. And finally, at the retail channels, we plan to send grade B and grade C fruits to our retail smoothie maker to hopefully decrease the E&O. Here's a close zoom up of our 3 solutions. And now my colleague Ali will further discuss the aerated static pile composting.
Thank you, Khalid. Let's start with defining the ASP. It is basically the system that involves arranging organic material in piles over pipes that force air through, speeding up the composting process. There are 3 main key features that we would like to talk about. The first key feature is the accelerated composting. Basically, the ASP system allows composting in a shorter time than usual traditional methods of composting. It would reduce the time by 50% when compared to other traditional methods. The second key feature is the scalability. Of course, ASP is suited for large volumes of organic waste. This would allow Dole to reduce the waste sent to landfills. Finally, the reduced methane emissions. The ASP could reduce methane by up to 90%. This reduction will align the sustainability goals of reducing carbon footprint. Moving on to the risks. The first risk is the system failure. The ASP needs fans, blowers, and other equipments. If any of these equipments is damaged, there would be a need for repairing expenses. The second risk is the workers' health. Some dust and particles would be produced while operating. This would affect the lungs of the workers. So this risk is also could also be solved in many ways. So it's not a major risk. The final risk is the strong odors. The system, if not implemented properly, would produce different types of odors that would disturb the people living around. And now moving on to the benefits. The first benefit is the environmental benefit. Of course, the ASP system would help minimize the methane reduction, the methane emissions, as we mentioned. Also, it would decrease the land waste, as we mentioned, and it would be there would be a new product line of nutrient-rich compost. They could also use renewable energy to operate the ASP system. Moving on to the social benefits, It would improve public health by improving air quality. It would also raise awareness in the society about food waste and showing commitment to the environment. And finally, the compost produced could be used to support the local agriculture. Finally, the financial benefits. We've calculated three different financial measurements: the MPV, IRR, payback period. We got 3.8 million MPV, 32% IRR, and 2.36 years of payback period. If you have any further questions about these numbers, we could talk in details more later on. And now my colleague Sam will continue talking about industry jelly and jam maker.
Thank you, Ali. So I'll start off to explain what this maker is and what it does. So this is a jelly and jam maker, which is used to repurpose fruits and turn them into jelly and jam. So it has a high capacity, which is designed for a large scale surplus fruit processing. And what it will be processing is the damaged or imperfect fruits, but that are still usable and edible. We want to make sure that it's not just fruits that are that may not look appealing, but that are still very much edible and delicious. So I will be talking about the benefits, risks, and financials. So to start off with the benefits, it would be repurposing fruits. So by repurposing fruits, we would take fruits that would otherwise end up in landfills, and we address this issue by creating them into a new product line. And this new product line would have a longer shelf life. With the conversion of fruits into jellies, we extend the shelf life because unlike fresh produce, which typically have a very short limited time until they perish, jellies and jams have a much longer product life. And then the new product line, this would also be a new revenue, and we could create partnerships with other companies and sell the jellies and the jams as raw material for these companies. With the risks, it would be a high initial cost. This would be a one-time expense, but with the maintenance and cleaning, it would be a lot of keeping up, and we would just have to train the employees to make sure that everything is up to date and standardized. With the packing expenses, we would also need to make sure that the packaging is also sustainable so that it aligns with those sustainability goals. So we would make sure that the packaging is eco-friendly, reusable, biodegradable, and all these other sorts of things. And then to talk about the financials, the NPV would be around 4.5 million, and this would be based off 20 machines, and the initial cost, which is a high initial cost, would be 7 million approximately. The IRR would be around 34%, and the payback period would be around 2.25 years. Now I will pass it to my colleague Jordan O'Connor, who will talk about the retail smoothie maker.
Thank you, Sam. Now I will introduce our retail store self-serve model, which was designed to address the issue of fruit waste in a creative and sustainable way. Here's how it works. First, our design is compact and convenient, making it easy to place right on store counters for customer use. Next, the machine gives near expiring fruit a second life by blending it into fresh smoothies or turning it into jelly. This way, the fruit stays out of the landfill and gets transformed into something customers can enjoy. It's connected to a basic user-friendly app with a loyalty program to keep them coming back. Also, on the retail side, the app notifies store staff when it's time to restock the fruit that's nearing expiration. This ensures less waste and keeps operations running smoothly. The machine is designed with simplicity in mind and requires only minimal training with 2 daily tasks. The first being daily fruit refilling once to twice a day, and then it's going to be basic maintenance to keep the machine clean and running smoothly. Now that we've explored the functionality of our design, let's talk about its market potential. We've seen how self-serve machines thrive in other markets. We have the self-serve milkshake machines in our local gas stations. They're successful because they offer quick and customizable options. These models show that customers value convenience, which sets a strong foundation for our concept. We think that there's a gap in large chains like Walmart where there's limited on-the-go healthy food and beverage options, especially for health-conscious customers. Lastly, retailers can benefit from promoting sustainability, which aligns with the values of environmentally conscious shoppers. By adopting our machines, stores not only reduce food waste, but also build a positive brand image. This combination of proven success, market need, and rising trends makes this a strong idea with the potential to reduce food waste and inspire others to adopt similar ideas. Now that we've covered our market potential, let's shift to how this model could positively impact both retailers and customers. For our benefits, customers will be walking around with a Dole logo printed on their cup. This machine doubles as a marketing tool. Customers in store, on the go, are walking advertisements for Dole. By adopting this solution, retailers can also position themselves as leaders in sustainability. While this concept has significant benefits, it's also important to consider some potential challenges. First being the initial cost of the machine. Second being staff training and maintenance. However, we hope that these processes can easily be integrated into daily routines through training. Third is the customer perception of near expired fruit. There is a risk that customers might view the use of near expired fruit negatively. To address this, we're going to focus on transparent marketing. Let's look at the financials behind this concept. Based off of 500 machines and the initial cost being $2 million, the NPV is going to be around $4.7 million. The IRR is going to be around 88%, and the payback period is going to be just 1.1 years. Now I'm going to transition back to Khalid to go over the timeline for these 3 projects.
Thank you, Jordan. So starting with our ASP composting, we have it's going to be our fastest project, as it's something that's already there and shouldn't take Dole too long to implement. That's why the R&D starts in the beginning of 2025. And if you notice in the timeline, it also is the first one to go full scale. Opposite to that is our industrial jelly maker. As you can see, the jelly maker has the longest R&D because it's going to take Dole some time to find which warehouses or distribution centers they want to use these machines and to allocate the space and resources for it. And then moving to our smoothie maker. For a smoothie maker, we're gonna use 6 months, half of 2026 for R&D alone, and then the rest of 2026 and half of 2027 to also launch a pilot project and commercial negotiations. These commercial negotiations is to make deals with the retail stores in order to get a nice profit share or profit split. And then the last 3 stages for all our solutions are going to be expansion and marketing, optimization and sales growth, and expansion and expanding nationwide. That's going to be it for our timeline. Moving on to our final topic, which is going to be the sustainability development goals. So starting with our ASP, it's going to be tackling climate action and life on land. Climate action, because as Ali mentioned, it's going to reduce methane, which reduces greenhouse gases, and that's better for our climate. Life on land is actually an SDG tackled by all three solutions. As all 3 solutions aim to decrease excess and obsolescence, this is going to decrease the land waste, being better for our environment. In addition, because our ASP is going to decrease the need for chemical fertilizer, this is obviously better for our land. Moving on to our second solution, the industrial jam maker, it's going to tackle both industry innovation and infrastructure, while also tackling SDG number 12. In fact, the third solution, which is a retail smoothie maker, also tackles SDGs 9 and 12, as they're both innovations which are going to help consumers consume in a responsible and more and in a better way, since we're going to be utilizing grapefruits B and C. In conclusion, these are the 3 solutions we present to Dole, each tackling different areas of the supply chain and hopefully decreasing their E&O. Thank you for your time.
Okay, thank you very much. That was a very nice presentation. So I'm going to go into the question period right away. Staying on this particular slide that you have, and that's the first question is, do you have any data on how much food waste occurs at each of these stages? For example, from your supplier farms, the grade D, what's the percentage of products that are grade D, and then in distributions, how much is on the grade C, and so on each one? So looking at how much product or waste is reduced at each stage.
Yeah, based on research, we found that in supply in the farms, there's about 30% waste.
30%, 30?
Yeah, 30. Not for Dole specifically, for the US in general.
Yeah, So in general, if 100 pounds of product is harvest, 30 of that will be actually wasted.
Yes.
Okay.
And also our ASP composting won't be able to reduce all of that 30. We can reduce 50% of that 30.
And then the next stage?
And then and the distribution, it was around 10%.
Okay.
And then for the retail,
Hmm.
I think it was around 20 to 30%, if I recall correctly.
Okay. So, so based on those percentages, you got 30%, and then another 10% on top of that, and then another 20, 30% of that. So that's where you came up with about, I think it was 50% of the food is wasted.
Are you talking about the ASP composting?
Well, in total, so from the harvest to the end and the end-to-end supply chain, how much food is wasted?
That won't be too clear because each it's gonna depend on the operations. Like that's something that Dole is gonna have to see with the research and development. We
Mhm.
assume in total, we know our ASP will reduce 50%. Our jam maker and smoothie, or our jam maker can reduce 70%, and our retail smoothie can reduce as much as the retail stores allows it to reduce. So it can take down the 100% in the retail channels, or 100% not including grade D. The grade D we won't be able to reduce in the retail channels.
Okay, so, all right, okay, I'm just trying to get the amount of product we're talking about at each stage. And then at your ASP composting, are you proposing that Dole sets up the composting plant, or would it be possible, is there an existing company that's doing this that it just sells the products to, or how do you see that happening? Who sets up this ASP of operation?
When we did the analysis, the financial analysis especially, we considered that Dole will start doing the ASP from scratch, like from the beginning till the end, the whole operation.
Why did you decide that versus perhaps outsourcing to another company that can do the ASP composting, and then Dole doesn't have to bear these startup costs?
So they could get the revenue back from the compost that is produced. So they could sell like a new product line, a new compost, nutrient-rich compost that they could sell as an extra product line instead of just outsourcing the ASP and then not getting the compost back for them. They could use it for
But
their
they would
farms.
get money back though, right?
Because it's still financially feasible. Like with our studies, even if Dole does all of this themselves, they have the land, they have all the land they need, they have the resources, and it was financially feasible, which is why we decided that Dole can do it themselves. If it wasn't financially feasible, maybe then we would discuss outsourcing it. But since it was financially feasible, we find that there is no need for us to outsource it.
Okay, so I can kind of see that for the first one where it is somewhat newer technology, the ASP. But for your second stage where you're making your jelly, your industrial jelly and jams, you also talked about starting up costs and setting up your own plants. Why would you do that when there are many existing plants that can do that for you? So why'd you propose Dole set up their own jelly and jam makers?
They wouldn't need delivery then, because the same place where you have, like when the fruits is sent from the farms to the jelly and jam, the machines are already there. I won't have to send the waste that's in the farm somewhere else. I'm avoiding a delivery cost.
Okay, so the jelly and jam makers are at the farm locations?
No, at the warehouses or the distributions. So they're
Yeah,
gonna be here.
so yeah, so that's what what I'm kind of having trouble with. So Dole would have many distribution warehouses throughout the country or the world that's closer to their local markets. And you would set up one of these machines or assembly lines at the distribution warehouse to do this, to reduce, I understand the reducing transportation costs, but the cost of setting up multiple assembly lines or production lines, how does that compare against setting up one central one, or just outsourcing to a third party that can do this? And they don't want, there might be some transportation costs, but have you looked at the alternatives to send it to this model?
Khalid, you can go to the appendix, please, to the raw data.
Yeah.
Yeah. So we did a model, a financial model, where we collected the data we could. Of course, this model could be adjusted during the R&D phase that we put for this solution, as Khalid mentioned in the timeline. So during the R&D, the company could research the other types of solutions. What we could gather was these type of raw data. So it was like how many quantities they might need. We ended up with 20 machines for the industry jelly makers, and the cost would cost them 100,000 for each, for example. So the total initial cost would equal to about $7 million plus the other, like the extra cost other than the machines themselves. And they would sell the jelly and jam each for $6. So after calculating all this stuff, we got a positive MPV and a very high IRR, which is a good indicator for continuing this solution. But if during the R&D phase they found out that there are alternative solutions that could bring them higher IRRs or higher MPVs, then they could go with the other solutions.
Yeah, I just wonder whether you've considered economy of scale. A company that just does this would probably be able to do this at much lower cost, right? Because they have the existing facilities, they could probably have high-speed bottlers and be able to do this quicker and cheaper. So that's something that I just wondered whether you looked at. And then my third question is on the retail smoothie, and it's not about the machine itself, but it's on your implementation plan. That's the one that you put in last because you thought there was a lot more R&D involved. And my thinking is that this isn't really new high-tech stuff. Why is this the last one to do when this could potentially be implemented right away? I think you can probably buy these machines and put a Dole sign on it, right? Is that the case, or is this something that's new and not available on the market?
The reason why it starts last in 2026 is because we're telling Dole to start all three solutions. They're going to be allocating the resources first to the ASP and the jelly maker, and then once some of the resources free up and the other two projects like got started running, they can start the smoothie maker. Because we felt like it's unrealistic if they go all in all three solutions, because that's going to require a lot of resources.
Okay, so this machine smoothie maker, is there such machine available on the market right now? Can we today go to tomorrow, like go out and buy this machine and put a Dole tag on it if we wanted to?
Yeah, there's similar machines. There is similar machines to this. Like for example, in Spain, when you go to some supermarkets or grocery stores, you can squeeze your own oranges and just get your own drink. So this technology does exist. There are similar machines there.
So the R&D is not really about making a new machine, right? So what's the R&D that you put in on your timeline?
It's studying which fruits work best with the smoothies, how you want to train the employees at the retail stores, like how they identify the fruit level C's and B's and things like that. It's more of like, okay, how do we get the program set up and how do we make it efficient? Because making the machine and putting a Dole sticker, you're right, it won't take that long because it exists.
Okay.
I would just like to add one thing to that. The R&D, the other machines that were mentioned, like in Spain, those are for fresh produce. So we're focusing on produce that's already in like grade C-ish. So that would kind of implement a different technology to make sure that that the whole fruit that is essentially still edible and can be consumed is split up from the parts that aren't. So that would be a difference between that and the other machines that are available.
So what you're saying that this particular machine that you smoothie maker that you're proposing currently does not exist on the market. This is something that Dole would have to do some R&D to develop this machine.
There are similar ones like Khalid had mentioned, but there would be some tweaking that Dole would have to engineer.
Okay, so there is some technology involved. Okay. My last question is, have you embedded any kind of technology in this so Dole can kind of keep track of how much food waste is reduced, or how much is processed through your jelly makers and Smoothie to monitor success of your KPI of your program? Like the end goal is to reduce food waste. So how would we monitor that?
Would you guys like me to answer it, Jordan, Sam, and Ali? Or
Sure, but can you please repeat the last part? I didn't understand the
Last
last part.
question, how would Dole be able to monitor or measure the success of this program? Because the end goal is to reduce food waste, right? So
Mhm.
how would they be able to measure that?
Jordan, do you want to talk about the app for the smoothie maker? Because I think that's related to the question. Then I'll do the other two solutions.
Yeah, I feel like with the built-in app on the smoothie maker, we're planning for it to be able to monitor the amount of pounds of fruit that's put in daily, and also the customers, returning customers. It's gonna be able to track that and collect data for us at the same time.
And then for the composting and jelly maker, for the jelly maker, it's just going to be as simple as us looking at how many jelly/jam have we produced in the year or the month. And for composting, we can just see how much fertilizer we produced or how much did we sell.
And you have any projections or estimations for your goals in your timeline that you're going to hit like certain milestones?
Ali, do you want to answer this?
Yeah, we did calculate like the amount of composting that will be produced based on the acres we found of the farms of Dole. So if Khaled, can you go to the appendix where we have the raw data of the composting, for example? So here it says that the total area of farms of Dole is 114,000 acres. The waste in tons per year is about 855,000. So the waste composted would be 50%, as Khaled mentioned in the beginning of the timeline. This would produce a revenue of the number we got, the total revenue, the 8,550,000. So as we mentioned before, these numbers could be adjusted based on the R&D. The final goal is to have 0% going to landfill. So as long as these three solutions are integrated together and reach the goal of 0% waste going to landfill, then they should go ahead with these three solutions.
Yeah, so basically what my question was like, how many years do you see it's going to take to reach that 0%?
It's going to take more than 5 years. We won't be able to tell now, but we do know like in 2027, all three, or like by the end of 2027, to be more accurate, all three solutions should be like, should have at least like 3 or 4 operations set off. Like by end of 2027, the ASP composting should already be in the majority of their farms. A jelly maker can be at around 20 distribution centers. It's not that many, but that's because it has the longest R&D. And the smoothie makers can be at least 500 stores by the end of 2027. For any other further milestones, it's hard to predict until now, because as you're going like 2025, 2026, 2027, you should be collecting data to see, okay, how much faster can I go, or should I be going slower? If we give any projections further than 5 years, or putting any milestones further than 2027, it's hard to stay accurate.
Okay. All right, our time is up. So thank you very much for the presentation and the answers to the questions. The results will be announced on December 20th. So best of luck to you all. And thanks again.
Thank you.
Thank you.
Thank you.
Okay,
Thank you so
bye-bye.
much.
Have a good one.